Okay, so once again, thank you all for joining us on this lovely evening. Hope you guys will learn something from today. What we'll be doing today is quite interesting. You'll be using my MySQL, PHP MyAdmin, and we'll be creating a few databases, running a few queries using those commands. So yeah, so there'll be a lot of interaction this evening. I will be doing a bit of in a way coding, but it's mainly in SQL. Okay, let's get to it now. I'm going to share my screen. Okay, before we go into today's lesson proper, I'm going to do a little bit of recap. Let me first get all my Windows set up before we start. I'm going to do a little bit of recap before we. Well, let me see if I can see if the waiting room is anybody. Okay, not yet. Okay, so I'm going to do a bit of recap from last week. So last week, sorry, Tuesday. So from okay, I'm going to go to this. So on Tuesday, we went to do a bit of relational algebra, and what we did primarily was to have a few queries, and then we tried to write the relational algebraic expressions from there. So one of the first things that we were doing was rather we let you guys try out in your little breakout rooms and try to find a solution. So I'm be running through these solutions. I ran through the solutions on Tuesday. The last few was a little bit rushed, so I think I would like to go through them very quickly again before we move on from there. So the first question, or rather, one of the questions that I went through a little bit fast was the students who applied for both MIT or Cornell. So what we are actually doing is that we are doing a selection. We're doing a selection. Doing a selection of the table apply. Okay, of the table apply, and the condition is that the person has applied for one of two of these schools, which is MIT or Cornell, which means that the S name is equals to either MIT or the S name equals to Cornell. Okay, so that's all. So this is the condition whereby if I were to run this by itself, it will return 4 columns. All 4 columns will be returned. Okay. So if I were to add in but in this situation, I only want to have the student ID. And so because I only want the student ID, I can do a project of my student ID. And this will return me only the students who have applied for either Cornell or MIT. Okay? Okay, good. So we went through this. Sorry. The next thing is for the students who applied for both MIT and Cornell. Naturally, from the previous example, it is actually quite natural to think that, oh, then I can just do a C name equals to MIT and C name equals to Cornell. And I apply this on the table called apply, and I do the projection of student ID. But of course, we discussed this last on Tuesday, that this is not correct. Why? Because this will try to find CNAME values whereby it is both MIT and Cornell, which can't happen. So of course the cell can't be both MIT and Cornell at the same time. So hence there's this error here. Oh, sorry. So what we should be doing then is, in fact, we want to do first the students that applied for MIT sorry. And I project the SID, and as well as the students that applied for Cornell. And subsequently, I want to do an intersection of these two. So this will give me the list of people that applied for both. If you go back to this example, this is going to give us with an empty null set. So no rows will be returned. If we go to this example, in this first query, I'll have 3, 4, 5. So MIT 3, 4, 5, 8, 7, 6, 5, 4, 3, and I will have Cornell 1, 2, 3, 3, 4, 5, 7, 6, 5. I don't have anybody. Oh no, yeah. So yeah, I have one. So 3, 4, 5 applied for both MIT and Cornell. So the return of this query will be 3, 4, 5. Okay. Okay, good. Okay, let's go on. I went through this. Find the students that did not apply to Stanford. So let's say one common mistake is I want to do a selection of my CNAME not equals to Stanford. Okay. Apply. This is one common mistake that people sometimes make. So this, what will this actually return? This is going to be return me this row, this row, this row, this row. So as long as it is not equal to Stanford, it's going to return me the row. So I will end up, in fact, with a huge superset. So I will have 1, 2, 3, 2, 3, 4, 3, 4, 5, and so on. So you get the idea. Yeah, the only time this would, yeah, so this is the incorrect query. Okay, so how should this then be managed? We would first have to find out who are the people that did apply to Stanford. So we do that by CNAME equals to Stanford, apply, and I project out SID. So this will give me the people that applied for Stanford, the SIDs that applied for Stanford, and then I want to project out only the SIDs from student, and I do a subtraction. Okay, there are a few things you want to notice here. The first thing is this is the people, the SIDs that applied for Stanford. So if I were to run this, I'm going to get this, this. So 1, 2, 3, 6, 7, 8, 9, 8, 7, 8, 7, 6, and 7, 6, 5. So this is the important part. Notice that this projection, I'm projecting it not from apply. I'm projecting it project from student. Okay, this is very, very important. Yeah, I'm projecting it not from apply, I'm projecting from student. If I were to project this from apply, I am going to get, if you say, if I project from apply, right, in English, right, I'm going to find the query I'm executing is the students that made at least one application who did not apply to Stanford. Okay, so if I were to project this from apply, it will be the students that made at least one application that did not apply to Stanford. So I want to ensure that I also get the students that made no applications at all, which is why the projection is not from the apply table, but it is from the student table. So I do a projection from student, and I do a subtraction from the student IDs that have applied to Stanford. And that's that's the solution for this query. Okay. All good. Any questions so far? Okay, done. I will go on to today's lesson. So today's lesson, if I put SQL, it's an SQL overview. Sorry, it's a SQL overview. So this is the basic introduction to SQL. So yeah, just some history. It stands for structured query language. Not very important. So it's not a programming language, rather it's a data sub-language. Actually, I never really understood what does this mean, but I just take it to be a form whereby it is a language that allows me to manipulate data using some predefined syntax. Yeah. So there are a few. It allows me to do 3 specific controls. One is the data definition language. Allows me to create, alter, and drop. Allows me to manipulate the data, insert, delete, update, select, and also it allows me to control access into the database, which is grant and revoke user accesses. So it is pretty flexible in that sense. So the database that we are looking at in today is this is the sample database. I have is Miss In here? No, Miss In Shu Yu. Yes. How many tables are there in this database? Oh, Mr. Sorry, I'm very sorry. Mr. In, I'm very sorry. Maybe I should stop calling the Mr. or Mrs. Mr. In Shu Yu, Shu Yu. May I ask how many tables are there? 5. Yes, very good. Yeah, so there are 5 tables that we see over here. So these are the 5 tables. Thank you so much, Mr. In. So these are the 5 tables that are there. So this is the sample database that we are going to look at for today. During the course of today's lesson, we will be looking at MySQL, and we'll be executing queries on that database. So this so firstly, the SQL for data definition is create. So to create database objects, database tables, to modify the structure and database objects. And you can also drop database objects like tables or views. Okay. So example is create database name. Okay. So this is how the create database command would look like. So at this point of time, I want this part to be really interactive. So I hope that most of you all have downloaded SAMPP. If you have, right, maybe I'll show you guys how to open this. So the first thing we want to check is that there is no conflicting database server that's running on your machine. So if there is, right, you need to kill it off. Yeah. So you need yeah. Let me show you how to kill. If so, when you first start you okay. So firstly, right, if you have installed SMPP, you will be in a certain folder. The thing you want to open is the control panel. So if you are on Linux, you have LAMPP. So that's the Linux version. So I'm on Windows, so I'm using the Windows version. So the two services that you want to turn on is the Apache service and the MySQL service. If you find that you cannot start this one, most often you have a conflicting SQL database that is on your machine, and you need to delete off that process before you can start this. When you first begin, both will be stopped. So I'm going to show you how is it like when I first So yeah, so hopefully most of you all have downloaded this. So go on to your control panel, double click the control panel, and you're going to start both Apache and MySQL. Okay, so what is Apache in this case? Well, Apache so-called is the web server that is going to be hosting your MySQL and all the other so-called services. So if I were to now go on to localhost, this is now the Apache web server that is running. So SMPP is the so-called the entire package. Yeah, so it stands for Windows, Apache, MariaDB, PHP. Yeah, that's what you see over here. So LAMPP, it will be Linux, Apache, Maria, PHP, and Perl. Okay. So this is the page that you would see if you have successfully Windows 7. What's Windows 7? Windows 7. Yeah, I think this is for Windows 7.3.11, but it will support up to Windows 10. So this is being updated very. I don't know how often, but this is a project that is ongoing, and for the longest time I've been using it. So yeah. So anyway, this is the main when you turn on the web server, which is for you turn it on from a control panel, you will be able to see this on your local host. When you start your MySQL, means that the MySQL database server will then be started as well. Let's say if I stop this and I try to go to phpMyAdmin. phpMyAdmin is a so-called interface for me to be able to access into my SQL. So notice that if I stop my MySQL server, I can't get in because the database server is not there. But if I were to start this, so it is listening on port 3306, which is the default port. Now it gets in. So this is the main interface of phpMyAdmin. Okay. On the left side, what you see over here are the list of databases that are there. So if you go into, I think there are some basic databases that are there. This is one thing that I'm doing right now, so no worries to show you. Another module I'm running. I can't remember why I have this anyway. So anyway, this is the list of cars that car sales that have been made. So you notice that these are the four. This is the table. So in this database 3102 Lab 2, so in this database 3102 Lab 2, there are two tables, car sales and movie listings. In car sales table, I have 4 columns, and these are the number of rows. Altogether, in this table, I have 1,000 rows, but I'm only showing the top 24 rows here. Okay, very good. So okay, so go to home. I hope everybody has a version of this installed. So if you don't have, yeah, just listen in. But I would really strongly encourage you all to try out, because then you can play around with yourself lah. Not play around with yourself. You can play around with this yourself. How this may work. Yeah, how this query works. So I mentioned that the last in the slide, right? The first thing we want to do is to create a database school. So notice that there is no school database here. So let's see if I do this, create database school. And I'm going to go. So notice that now my school database is created. Okay, so if you have this on your laptop, again, I highly encourage you all to try this out, because it's always good to play around with all these, and you get very familiar with this. Okay, so firstly, I have created my school database. If I were to go into my school database, I will notice that there are no tables in my database, because I just created it. So naturally, there are no tables there. So the next thing I really want to do is I want to create a few tables. So let's go back to, I'm going to switch between the slides and the thing quite yeah, here and there. So the first thing is create database, and I created the school database. And of course, I can create not just the school database, I can also create the tables. So it is all using the same command, create a table or create database. And I have the table name. So this is the table name, and these are the various columns or the attributes, which we will try to do it now. So let's go back to the SQL. So I'm going to create table student. So this is the table student that is being created. Within the student table, there are various columns. So one of it is SID, and SID is of 8, character 8. And this is a primary key. Okay. So this is the first column that we have. We are going to create a few other columns there. Other than SID, I also may want a name. And I want to set it to be not now. I have the gender, age, integer, character, the department ID, which is 2 characters, and the grade. Okay, so these are all the columns of the table, and yeah, so this is how we create the entire table for students. Okay, if I were to click on go, yeah, so notice right now I have a student that's being created, and this student table has these 5 columns, and there are no rows there because we didn't add anything there. Okay, it's all able. Everybody still able, can follow what I'm doing, and all is good. Okay, that's good. So we have created this table. Notice that I have to specify the primary keys using the so-called primary key command. But I can't. Yeah, yeah, and yeah, and Yeah, so I specify the primary key to this. Now I'm trying to add one person is in the waiting room, B Ching, but I can't add the person in. I don't know why I keep on trying, but I can't. Yeah. Okay, so yeah, so next. So right now we created this student table. Also, sorry, these are two different ways of creating this student table. So in this query, notice that I don't have a primary key. In theory, I can still execute this. It will go through, but then I will have to. They will throw me a warning that this table has no primary key. But it will still allow me to go through. So what I really want to do is I want to have a primary key over here. Sorry, if there's a person that knows who B Ching is, right? BCHNG. I've been trying to add in. I've been trying to allow him in. Oh, okay, at last. Yeah, no, but I don't think he's in. So I've been trying to allow him in for some time. He can't get in. Yeah, so let him know. Maybe he can exit and then try to join again. Okay. So yeah, so this has a primary key, and the rest of them this does not have, and so we want to add a primary key in our command. Similarly for table calls. For table calls, I'm not going to type it. I'm just going to copy this into my, because it's going to be pretty similar. Yeah. So now I have a second table. I have a second table, which is student and course. Yeah, so course is over here right now. Okay, very good. So the next command is a interesting thing. So earlier we have the primary key that is attached to an attribute. In this next one, the primary key is supposedly a composite key. So let's try to look at how we do this together. I'm talking to you now. Yeah, I keep on hanging. Excuse me. Yeah, remember. Yeah, thank you, Ryan. Yeah, remember the mark attendance. Any reason why some primary keys are not now? So okay. So I think I mentioned I sort of shared this very briefly in one of the previous sessions. You actually can somehow you can allow your primary key to be null, but you can only allow one primary key to be null. So, or rather, you can only allow one table to be one entry to be null. So okay, but it don't make sense. Okay, thank you, Ziquan for talking to B Chen. Yeah, actually, I've been trying to admit him for I think the last 5-10 minutes, but he keep cannot get in. Yeah, so thank you so much for helping out. Yeah, so yeah, I was talking about this issue this on why primary keys can be null. So let's say if this is SID and this is the primary key. So it is sometimes a strange thing, but some database implementation and MariaDB included, right? And MariaDB included is allows a null value here. So in fact, you can enter a null value as a record in the primary key. Okay, so this maybe let's say course ID, which is 23, name, which is A, B, C, something else. Yeah. So you can actually do this, and they will allow this insertion in. But the interesting thing is when you try to insert in another row, also with now, this will reject. And the reason it rejects, right, is not because my primary key is null. The reason it rejects, right, is simply because it cannot have a duplicate primary key. So the error that it throws out instead of saying that it's a null primary key, is that there's a duplicate primary key. So in many implementations of the database, they allow you to have a null primary key. but of course it's not recommended. It's definitely not recommended, and yeah, and we shouldn't do that lah. So if I go back to this. So right now what we have is we have student, we have course. I am going to create a table called RC, which is the courses that a student is enrolled in. So for this, I have SID, which is character of 8, CID, which is character of what did I use the last time? Character of 3. CID and score, which is a float, and primary key, SID and CID. Let me see if I get this correct. Let me see what I use 8 here, so I should have 8 here instead. CID is 3. Okay, this is good. Okay, all good. Okay, so yeah, so character, so it has both the SID and the CID. It keeps a score of the grade that the person did in the course, and the primary key in this case is both the SID and the CID. So I'm going to run this now. Okay, so I have this SID, CID score. We can look at the structure over here, which says that SID and CID, they are joint primary keys. So what we showed earlier is a way to create a joint primary key of both SID and CID. Okay, then there's this question. What if we don't have a joint primary key? What happened to this table? If our primary key is just SID alone, if our primary key is just SID alone, what will happen? So if our primary key is just SID alone, right, means that one student can only take one course. Okay? Because I cannot have a case whereby I take 211 and then I also take 365. This will have an error. So this cannot be a we cannot have a situation like this because this is a primary key. If there's only one primary key, and which is the reason why we need to have a joint primary key here. If we have the situation whereby I only have CID to be the primary key, what would the meaning behind that is that the one course can only take one student. So this is the physical meaning if only my CID is the primary key, which is one course can only take one student. Okay. Okay, good. So good. Okay, so we are good with this. The data types that there are various data types that you can have. So character, variable character, integer, numeric. So I can just read through this. And now we go to the job. So job, you can drop table or drop database. So right now I'm going to do a job. So I'm going to do a drop here. Let me see if I have a drop table and a student. Yeah. So you notice that my table table is drop. And if I drop table RC, so my table RC will now be dropped. And if I have a drop database, notice now my entire database is now dropped. Okay. So this is how this this drop statement works. Okay. Okay. Then of course we have insert into, update, and select. So but notice that we have nothing here now. So of course we can't do anything. I'm not going to create the tables again. So what we're going to do right now is this. So we can import data into the into the database. So on the Moodle, right, I have included I think one executable, not executable, sorry, one let me find the actual the I think it's lecture04.sql file. Looks like this. Yeah, so you should be able to download this. So automatically we can sort of upload a script which creates the database, creates the tables. It's all here already. I'm going to tweak a little bit of numbers here. This is 3. Instructor IID, instructor ID is 3, which is fine. And okay, CID, okay, yeah. So this, okay. So yeah. So this is the file that I uploaded onto the Moodle. And what you can do right now is we are going to do this together, where we would import this together. So I'm going to import. Excuse me. So this will be lecture04.sql. And I'm going to press go. So so there are 27 queries altogether, and all have been executed properly. So notice that my school database is now up. I have 4 tables here. In my course table, I have 3 rows, 211, 255, 228. In my student, I have these people in Amy, Alice, Bob, Kathy, and John. That's what we have seen in the earlier segment. So I now have in a way a micro database in our on the system, which I hope you all will be able to replicate this on your own laptops as well, so that we can do queries together and we can learn together, hopefully effectively. Okay. Good. So let's see where we are. So these are some of the ways where you can use to manipulate data: update, delete, select. So I'm going to do this one by one. The first thing I'm going to do is actually I'm going to delete a certain record. Yeah, why? Because I'm going to demonstrate insertion. So in order to do that, I want to be able to delete the record. So I'm going to do this now. Delete from student. Student ID equals to, I'm going to use 4002. Okay, so right now you notice that my student 4002 is gone. Okay, I'm going to do another deletion. So 401. Okay. So right now I have manually deleted 2 of my entries in my database. And I'm actually, the main reason why I'm doing that is because I want to demonstrate insertion. So that's it. Okay, so deletion as well. Okay, so I've gone through this. The next thing I want to do is to append, is to insert. So let's say I want to insert Amy back into the database. So which are student 401. Okay, let's do this together. So the command is insert into student, which is the name of the table, values, 401, Amy, F2003, SOPHOMORE. So this is the insertion command into my student table. Oh, okay. Hey, another gentleman here. Okay. So if I were to go execute this command, I will have inserted this student into my student database. Okay, see, Amy is now inserted here. Okay, so in the back to the notes, I may not have all my fields ready. I may want to insert only a partial part of the row. And in that situation, I can use a command which specifies exactly the rows that I want to insert them in. And this goes in this form, which I'm going to show now. So I'm going to insert into student. So notice that this insert into is the command, and then the next thing is the table name. So insert into student, SID, as name, gender, and DID. So let me go through this. So student, the structure of student has these 6 fields. And right now I'm going to say that I don't have all the 6 fields. I only have SID, S name, gender, and DID. So how I can do it is that I can, instead of having to maybe have dummy values or null values or whatever, I can just specify which are the columns that I want the insertion to occur in, and I will then specify the values 402, Alice, female, 4. Yeah, so that's it. So if I were to look at student, so notice that now Alice is there, and this will be now. Okay. Let's try to do one more query. So I have, let's say, insert into student, SID, gender, values for, let's say, 5,000, and M. Okay, let's see what this happens. No, it inserts as well, and S name is empty. Why is S name empty in this case? Notice that all of these values are actually null. But in this particular situation, S name is given the value of blank. And the main reason why is because we have specified it to be not null. We have made sure that the default is empty and it can't be a null value. So that's why S name is going to be a blank. I'm going to illustrate this with one more funny example. So I'm going to insert into student UD, and let's try this. Gender, values, M. You think this will go through? So I believe this will go through. Actually, I didn't try, but I believe this will go through. Yeah, it goes through. And what will happen is it's going to be the same thing. Instead of being a null value, it's going to be a blank. Okay. So I'm going to illustrate this. If I were to do this again, so insert into student. What is it? Let's do S name values. Why like that? Let's do this. No. So once you notice that now I try to do this again, but now that it gives me an error. And why is this error? It's not the error is not that my primary key is empty or my primary key is null. The error that is throwing out to me is that my primary key is duplicated, meaning that I already have one null value in my primary as my primary key already. And because I have not one null value there, I cannot have another null value there as well. So it's a very interesting nuance of databases. So this is just important. And to be frank, I don't really know how to query a blank SID as well. So maybe later during the break I'll try this. But I really don't really know how to query a blank SID here. I'll try this later during the break. Okay. So basically that is about insertion. And so we have gone through these two queries already. Let's look at the next one. So right now, I want to append, insert. So let's say if I want to let me get this. Actually, I want to do. Yeah, let's do this one first. Yeah, let's say I want to update the student. So notice over here, 401, I have age which is 20. And I want to update this age to let's say 19. So what I do is that I will then do a update student set age equals to 19, where SID equals to 401. Okay. So now my Amy's age has been updated to 19. My temperature right now is 37.9. Okay, no problem. Okay, understand. So now okay. So I demonstrated how we can change one particular entry over here. Let's look at another query before we go for the break. So I think student 402 has nothing at all. Update student set age equals to 22, where SID equals to 4002. Yeah, and right now if I do a browse, where is it? Yeah, so now it used to be now, but now there's something here. Okay, let's try to do one more fun thing. I can actually do this. Update student set. Let's try if this was not. SID equals to 6,000, where SID equals to. Let's try to see this was not. I have no idea. It works. So I managed to clear off my blank primary key with I can in fact clear my blank primary key without this statement. Okay, so okay, that's it. Let's a bit of fun here and there. So anyway, the time now is 9:20. So I think we should have a short break now because it's a long evening. Let's take a very quick 9 minutes break, and we'll come back at 9:30 to round off the rest of the discussion. Thank you so much. So before the break, we were doing on the creation of tables, databases, insertion of records, and also how we can import databases into the PHP MySQL database. Subsequently, we also look into how we can manipulate data by insertion, deletion, and updating of certain fields. So we did that with, we were playing around with some of the commands, inserting empty primary keys, inserting and trying to update the primary keys by and by. Okay, so that was before the break. Right now, we are going to look at how we can use some mathematical formulations, even to update some of the fields here. So say I have this update instructor set. I can't remember the workload equals to workload times 1.1 where instructor ID or DID or department where certain department equals to. So I want to increase the workload of all the instructors within a certain department. So this is the query that I can execute. And if I do that, notice that the workloads have been increased by 1.1. Maybe I didn't show it very clearly earlier, so maybe that's yeah. But initially it was I think 1.5, 1.5, and 2 and 2.5. So they have all been increased by about 10%. Okay, so that is how we can have an update query with a mathematical formula here. Okay. Then this is another query, which is I want to update query, but it is more in terms of quite like a nested statement. So in order to understand this, let's look at what this is talking about. I want to select the ID, the name, from student where my name ends with the letter Y. Okay, so basically this is what this statement is trying to say. I want to select both the SID and the name from a student where my name ends with letter Y. So let's select SID as name. Is this name? As name from student where as name like Y. Okay, so let's select this one. So now I have Amy and Kathy. So both of them, they have names that end with the letter Y. So basically what is happening is that this statement is selecting all the records where the name ends with the letter Y. And I'm projecting only the SID and S name. And I'm going to insert it into a new table, SID and S name. I don't think I have the table here. Yeah, so I don't have the table there. So maybe I don't. Let's see how we can do this. But if we look at this from a relational algebra kind of view, my selection is actually here. Select as name like Y from student, projecting out my SID and my S name. So this is how I convert this entire SQL query into relational algebra. Okay, all good. Okay, very good. And so we learned earlier this query returns us with two records, and if I were to if I were to call this, I would in fact be inserting these two records into this database here. Okay, let's see how we can do this. Okay. So I have SID. Yeah, let me try to do that. But let's try to create this new table. Create table, and the table name is st. And I think only two attributes. Is it SID and character name? SID, which is character name, and S name, which is character head. Let me check. Oh. Okay, there's no primary key over here. Okay, so now I have created a new table called ST with only two columns, SID and SName. So we call the earlier query that we called this one. So this selects, excuse me, this selects the name of the students with the SID and names of the students that end with the letter Y. And the next thing we want to do is I want to insert this, insert into ST. We're going to put it in line, insert into ST. Yes. SID as name. Okay, let's try this. So right now, what I did is like something like a complex query, whereby I first did a selection in my inner query, and in the outer query, I did an insertion. So what I'm expecting to see will be these two people with SID and SName, and the names will be ending with the letter Y. Okay. Okay, very good. Any questions so far? Okay. 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 Hope there are no. Okay. Hope everything is okay. So this is how we convert between a simple query to a relational algebraic expression. So we have usually a selection of a few columns from the table where a certain query condition comes in, and the query condition usually comes in the sigma operator. The selection criteria comes in my pi operator, and the table is the table table name over here. So, okay, so there's some examples. Query all the student names. So let's try to do this together. So if I want to query all my student names, let's see if is Alex Chu, Mr. Alex Chu, are you here? Okay, what's my what do you think is my SQL query to query all my students' information? I will have to. Oh, sorry. yeah, select. So what do you think is the statement to retrieve all the information from my student table? Maybe I can help you with this. So this will be select star from students. So this is how we would return all the students' information from the database. Okay. So yeah, so if we convert this to relational algebra, this actually is just a pie of students. So there's no selection criteria. We're going to return everything. So star returns all the tables. So if let's say in very good example, very good question, Mr. Yeah. So if I want to return only the name and the age, I will have to do select name, age from students, and this will be select as name, age from students. Okay. So this this query is here. Okay, let's look at the third one. Return name, age, and name for students who are under 19. So I want to select age and name from students where age less than 19. Okay, so this is how we write the query out. If we want to convert this to relational algebra, so this would be I want only the age and the name, age less than 19 from students. Okay. Okay. Okay, let's try to do this together very quickly. So I want to select from student. So yeah, so now I select all my students from the student table. If I only want to select what was the name and age? Name as name, age from student. Notice that I only have these two columns that emerge. So only the name and age of all students. So this is what it gives me. So if I only want to select name, age from student, where age less than 19, I should only get Kathy's name. Only yeah. So I'll select the name and age where my student is less than 19. So only this lady will come up. Okay. Okay, let's go on. Excuse me. So if I have multiple criteria to match, then you can use and or not to connect the various criteria. So for example, if I want to return the ID of students that take either 211 or 255, then I can do a select. Select SID from students where CID equals to 211 or CID equals to 225. So this will be the correct answer for this. So this similarly to what we did to the example that we did earlier, this is going to be I'm going to project out my SID. CID equals 211 or CID equals 225 student. So this is the query over here. Okay. Okay. So the next one is how about people that take both 211 and 225? So a common mistake again, like what we did earlier, is to change this or to an N. But of course, this is going to be incorrect. So you actually won't be able to do this. So this is incorrect. So what the solution is, we want to join with itself. That's one, or use the keyword in, where we will have to do the intersection between two of these queries. We will do this later on during the lecture. The student table does not have a CID column. Oh, sorry, it's not student. Sorry. Thank you, Wong Woon Kiet. This should be RC. Yeah. For the ST table, yeah, correct. Thank you so much. Yeah. This my mistake. This should be RC rather than students. Excuse me. For the ST table, is there a primary key? There's no primary key for that. So the ST table I just created. Yeah, I just created. So in this case, right, there's no ST table. It is just the name of the people, SID and name of people with the ends in letter Y. In this situation, there's no primary key. So yeah, so that's how to say, there's no primary key here, and it is also perfectly fine for a table without a primary key. But if I were to want to have a primary key, then I can always make SID to be the primary key. Okay. Any other things I want to point out? I think that's what I want to. Yeah, later I'll show how to do the query for the both 211 and 225. Is there anything else I want to point out? I think that's it for now. Okay, let's. I think that's it for now. Okay, let's go to the next one. I want to be. Let's say if I want to have the distinct ID of students that has a score greater than 80. So firstly, I do a. I don't know why the first time I must select. Let's say if I do a select ID from RC where score greater than 80. So if I do this, I may have this column, or rather I'm going to get this row, this, this. This will give me 4001, 4001, 4002. So in order to not have repeating student IDs, I need to put in a distinct keyword here. So this would allow, or rather this would ensure that all my IDs like that return are distinct. So I can also arrange something according to a certain order. So for example, if I want to return student IDs and name in ascending order, ordered by the student ID, I can select ID, student name from say student order by student ID. Okay. If I want to get the scores of the course 211 and the list them from high to low, I can select student ID score from C, where CID equals to 211 order by score descending. Okay. So these are various ways we can execute these commands. Okay. So maybe we can let's see. I can try to run them on the page map. So let's see. I have I'll see. Okay, I have the data here. So let's look at what is my first query. Return ID of students less than 80. Select start from RC where less than score. So if I were to run this, notice that it's going to give me everything, and I want my SIDs to be unique. So I want let's say if I have SID, I'm still going to get duplicated SIDs. So the right way to do this is that we want to do a distinct, and that will give me the distinct values of SID. Okay. Return student IDs and name ascending order by student ID. So return so student ID and name. Okay, so I'm going to select student ID, student name from student table order by student ID. Yeah. Yeah. So this is ordered by. I'm going to select from the student table. And I'm going to select just two columns, SID and SName, and I'm going to order it by student ID. So return scores of course 211, list them from high to low. So select SID scores from RC, where CID equals to 211. Order by scores. Let me see this guy. So there's an error. Order by, there's no scores. I think it's 4. Yeah, it's 4. Yeah. So so this is how we can execute the query in this manner. Okay. Okay. Oh, okay. I hope you all are following and also trying this out, because it will help the learning. It will help the learning. Rather than me just saying like that and you looking, if you were to type out the query, it actually reinforces the learning quite a bit. So well, hopefully you have the chance to do it. Okay. So we look at a bit of wildcard earlier. So this wildcard, these wildcard characters are either like a percentage sign or like an underscore. So this tells me I want to return students where my name starts with the letter A. Excuse me. So in this case, it will be both Amy and Alice. In this, it tells me I want to find students with 3 letters, and it starts with the letter A. Okay. And this is the students which don't start with the letter A. Okay. So I can just do a quick thing. Select start from student where as name like A. So I have these two. This is 3 letters and starts with the letter A. So I have Amy. If I have not, so these are people that don't start with the letter A. So all the rest. Okay, so this is how we look at these 3 queries. Okay, so far. Okay. Let's go on. So let's say if I'm querying multiple. So right now we are going to querying of multiple tables. So is where the join effect comes in. So you notice that there is this Cartesian multiply operator over here. So this is where some joins actually come in. So let's say if I want to return the scores of database of all students, list their names. I'm not going to do this. So let's say I want to return the scores of all the scores of the course database for all the students, list their names, their scores, and sort the result in descending order by score. So notice that there's a lot of things going on here. So you want to return the scores of the course database for all the students, and I also want the student name. I want the score. I want to sort the result of the this result by descending order by the score. Okay. Let's look at let's break this down bit by bit to see how we can understand this. So the first thing we want to do is we want to find what do we want to return. Okay. We want to return the score. Definitely need the score. We want the student name. And I think that's about it. So in my selection, I will have a select. So I have an S name. Oh, and I have a score. Okay. So this will be the 2 columns that I'm going to project out. The tables I'm going to be using will be all 3. So I'll be from student, RC, and the last table is course. So this will be the basic framework of how the query will look like. So there's going to be a bit where, which we are going to not do now. But we know that there's order by. And order by is going to be my score. And he wants it to be descending order. So far, nothing new has come out. So all these are as what we have discussed earlier. So far nothing new. So what we want right now is that we learned that in our earlier part, it requires joins. We are going to require a join between these three tables together. Okay, so we need a join of these three tables together. So the first condition that we have is the name of the course is database. So I will have so C name equals to database. So this is the first condition. Okay. I want this database, which is this. And in this case, right, my CID will be a foreign key, or rather this will be a foreign key of my CID, in a way, primary key over here. So there needs to be in a way, you can call it a natural join, or you can just call it, in this case, like a typical teaser join of these two tables. And so there will be an N. Let's say this is my course dot CID equals to my RC dot CID. Okay. So now my database name is database. My course dot CID equals to my RC dot CID. And I also want to link these two up together. And I know that these two are so-called can be joined together by the SID. And so RC dot SID equals to my, this is my student dot SID. So this is how the query would look like. Okay. Any questions on this query? Okay, good. Okay, let's look at the next thing. Oh yeah, so this is the solution. Earlier I mentioned that there's alias is actually quite important. So yeah, so when we're doing the projection, it's very, very important. Why? Because we want to be able to join with itself. So that is where that's why it's very important. So we're going to look at how it's going to be used now. So when you call alias, right, you from table, this we can just put the alias as the next so-called variable. So the next will be known as the alias. So thereafter, when we refer to alias one, it is known that it will be referring to table one. You can do alias in this manner, or we can use an S keyword as well. So this will also have alias two to refer to that of table two. Okay. Okay. So we're going to go back to our earlier example of how do we find the students who took both courses C211 and 225. So so let's look at, we want to select, let's break down one step by step. We want to select the S name. So this is what we want to get. Okay, we want to select the S name, and the table that we want to join it with is, this is the student table, and this is the RC table. And let's assume that, I mean, not assume, but we know from the previous relational algebra that we will need to do a so-called a join of RC with itself. Okay, and then so as to be able to find out who is the student that has 211 and 255. So if you recall, what we did the last time was that we did a teeter join between these two with SID of this to be equal to the second SID as well. Okay, so if you recall, that was what we did in the last time. Okay. So we want to select the student name from student table. And we also going to have RC. And let's say we call it RC1. RC, RC2. So this will be the three tables that we are going to be executing this query from. Okay, so far? Okay, so the next part is where we want to be very clear. So the next part is, I want my student ID here, so my student.sid to be equals to maybe RC1. So this is RC1, this is RC2 dot SID. Okay. Okay. And remember in our relational algebra, I also want my RC. Oh, my RC. What happened to my mouse? Okay, sorry. Hello? When did I lose you? Sorry, I think I got disconnected or something. Yeah, yeah. I hope the recording. I think the recording is still okay. Yeah. Sorry. Yeah, I'm back. I'm back. So I never 阵亡. Okay. So anyway, okay. So okay. So sorry that I don't know what happened. Wait. Okay. I'm going to go through this very quickly. I have 2 minutes. So wait. May I ask? Where did I lose you guys at? So RC, okay, very good. Thank you. Thank you, Mark. So I lost you at RC1 and RC2. Okay. So let me RC1 and the answer is that RC1 and RC2. Okay, student. Okay, so so you select. Okay, I have sorry for the interruption. Thank you for understanding S name from. So we mentioned that we need a student table. We need RC as RC1, RC as RC2, and yeah, and where we know that SID must be connected to this SID student dot SID must be equals to RC1 dot SID, and from our relational algebra example, we know that RC1 dot SID equals to RC2 dot SID. And now we want to know causes 211 and 225. So RC1 dot CID equals to 211 and RC2.CID equals to 225. Okay, so this is how we solve this. This is how we find this solution. Okay. Is there a shorter version? I think there may be a shorter version. I think the shorter version is a nested query, which I think we may go through. I think we will go through that in our lecture 5 or 6. Yeah. Okay. So the time now is 10:10. I don't want to hold you guys back. I'll be around here to take any further questions. Yeah, but yeah, if there are none, then thank you so much for your evening. Sorry for the crash earlier lah. So I don't know what happened. I think my internet got disconnected or something. Yeah. So thank you so much for your time. I'll wait here for if there are any other questions that may emerge. But if you have none, do enjoy the rest of your evening and also the weekend. Thank you.